Hello, my lovely students. Welcome to the first chapter of your 10th standard mathematics, real numbers. So, everyone are familiar with the term, right? Real numbers. You have studied about this concept in your ninth standard also. Remembering, like in ninth standard, you have understood the number system, irrational numbers, and what are the properties of irrational numbers. And in your primary school levels also, you heard about numbers like multiplication of number, division of number, and you are doing other operation like addition, subtraction, so on. So, what is this real numbers? You already have an idea about this real numbers from your previous classes. So ಇಂದಿನ ತರಗತಿಯಲ್ಲಿ ನೀವು ಆಲ್ರೆಡಿ ಇದ್ರ ಬಗ್ಗೆ ಅಭ್ಯಾಸ ಮಾಡಿರ್ತೀರಿ. But what we are doing in this class, we are going to understand what are the different classification. That means we are going to understand the exact number system. I know you people have already have a clear idea about it, but let me revise those concepts so that we are going to understand the exact important theorem in this chapter, the real numbers, the fundamental theorem of arithmetic, what are its application. So everything we are going to understand in detail. So in order to find that, first let us go through the basics for this chapter. See, you have a number line system and she is your new friend Swati. What Swati is saying like, she want to know the number system in detail. She is like saying like, ma'am, I don't know. I already forgotten the number system I studied in my ninth standard. I want to revise all those concepts. Please help me. So I know you people are very good at remembering and you know what are number systems, what are natural numbers, whole numbers, everything. But let's help your friend to know about number system in detail. So what Swati is doing now, she is doing an activity. You have seen, right? This is a number line system. It consists of three parts. Zero, and this is the positive side of the number line system, and this is the negative side of the number line system. That means it have positive numbers, the left side having the negative numbers. What Swati is doing now, she is just moving right side of the number line system, and she is going to collect all those numbers and putting it in a circle. So what is this collection called? These collections are called as natural numbers. Natural numbers are the counting numbers that start from 1 and counting indefinitely. That means 1, 2, 3, 4, all these are counting numbers. Can you say like 195, 2, 5, 6, 8, 9, 2, 0? This is also a natural number. That means numbers having an infinite value, right? It will keep on continuing. Like take another example, 3, 4, 5, 6, 9, 8. Take any random number. So this kind of numbers are called as natural numbers. Hope you carefully observe it here. It contains only positive sign. It's not a negative number. That means natural numbers do not include negative numbers. See, Swati just start from 1 and just moving right side of the number line scale. And it does not include 0. And these natural numbers, we are representing it by the term L. Okay. So now what Swati wants to do, she just want to come from the same direction and she stopped at the point 0 and she want to put it in the same circle. And this collection of numbers are called as whole numbers. Whole numbers are the collection of all basic counting numbers. So what you mean by counting numbers? In the previous slide, what we have understood, all counting numbers are called as natural numbers. That means whole numbers contains both natural numbers along with 0. This is called as whole numbers. These whole numbers, we are representing it by the term W. They do not include fractions, decimals, or negative numbers. So, what you mean by fractions, decimals? You already have a basic idea about it. I will explain it in detail in the next slides. So, whole numbers do not contain these negative numbers or fractions, or decimal means 0.1, 0.2. So, these numbers won't come under the classification of whole numbers. That means, from the definition, what we can write, whole numbers, it contains natural number as well. So we can write it like this, right? Take any example. Take 5. 5 is a natural number also and 5 is a whole number also. Take 2. 2 is a natural number and whole number as well. Take 0. Whether 0 is a natural number? Yes or no? No, right? 0 is not a natural number. That means whole number contains natural number along with the 0. Next, what Swati is doing, she is just moving to the left side of this number line cycle. What you are seeing in the left side, you are seeing the negative numbers. So she want to put all these negative numbers in one circle. So if you see, now the circle has both the positive numbers, 0, and the negative numbers. So what this collection we are calling? We are calling this collection as integers. What do you mean by integers then? Collection of both positive and negative numbers, including 0, are called as integers. These integers, we are representing it by the symbol Z. Clear? So take only any one example. 3. 3 is a natural number. Correct. And this 3 is a whole number as well. And this 3 is a integer as well. So that means we can write in the previous slide what you have understood. Whole number consists of natural numbers as well. So again we can write this integers. It contains both whole numbers and natural numbers. Because it contains negative numbers also. These negative numbers won't comes under this whole numbers. It's clear, right? Next, go to the next topic. Okay. Swati covered all the numbers in the number line and put it in a circle. And we understood the concept of natural numbers, whole numbers and integers. Do you see any other kind of numbers here? Positive numbers we covered, negative numbers we have covered, 0 also we included. Any other numbers are there? Rational numbers. So what do you mean by rational numbers then? Take any one example. 1 by 2. So 1 by 2 means 0.5. So where this 0.5 comes from? So it comes somewhere between 0 and 1. Here you are getting this 0.5. Correct? Take another example like minus 1 by 2. So this will give to minus 0.5. Where you are going to locate this minus 0.5? Here in the left side of the number system between 0 and minus 1. Minus 0.5. So, rational numbers are the numbers which are representing in the P by Q format. Here, 1 by 2, I can represent it in the P by Q. That means numerator by denominator format, where Q is not equal to 0. What will happen if Q is equal to 0? Basic mathematics, like any number which is having denominator as 0, its value is undefined, or we can call it as infinity. So for any number which has to be called as a rational number, we have to make sure the denominator should not be equal to 0. Now, see, the actual definition is a number R is called a rational number if it can be written in the form P by Q, where P and Q are integers and Q is not equal to 0. What do you mean by this integers? Integer means what? Collection of both negative and positive numbers and including 0. That means rational number is already having the integers it's in collection. And also whatever the number we have written in the number line, all those numbers can be expressed in P by Q format. For example, you have number 25. So it is in P by Q format. You are saying like, ma'am, rational numbers should have any numbers in a P by Q form. But 25, it's a number only. How it is come under P by Q form, you are asking. See, whatever the number, by default, these numbers are having 1 as a denominator. Now it becomes P by Q format, right? So, rational numbers consists of integers. So by the default, what integers consists of? Integer consists of whole numbers and natural numbers. So that's what the rational numbers also include the natural numbers, whole numbers and integers. The next concept is irrational numbers. What do you mean by irrational numbers then? Opposite to rational. See, irrational, opposite to what exactly rational numbers are. What do you mean by rational numbers? Any number that can be written in P by Q form are called rational numbers. So what do you mean by irrational? What is opposite of P by Q form? Any number which cannot be written in P by Q format are called as irrational numbers. Simple, right? These are all the basics only. I know you already know about these topics in detail, but just revise the concept what you have understood in your ninth standard. Okay, what are the examples of irrational numbers then? Square root of 2, square root of 3, square root of 5, or you can have the pi value. See the pi value, it is having the value like 3.141592. Can you carefully observe? This is the decimal expression and these numbers are not repeating. They keep on increasing and its value is infinite. These kind of numbers are called as irrational numbers. You may have doubt, ma'am, we have root 4 also. Can this number be an irrational number? Do you think so? Square root of 4 is an irrational number? No, right? Because we have a value. Square root of 4 is 2. Then this number won't comes under irrational numbers. All these numbers like square root of 2, square root of 3, pi value, this Euler's number, these kind of numbers comes under irrational numbers. You already learnt about the properties of irrational numbers in your ninth standard. Just revise the concept, what is the definition of irrational number, so that in the upcoming classes, in this chapter only, we are going to learn some more properties of these irrational numbers. Okay. So this is the summary of the number system just we studied. So natural numbers, what you mean by natural numbers? All the counting numbers. What you mean by whole numbers? Now natural numbers plus 0. It contains whole numbers. So what you mean by integers? All positive numbers, 0 and negative numbers are called as integers. What do you mean by rational numbers then? Numbers are representing in P by Q form are called as integers. We are coming to the next concept, irrational numbers. What are the irrational numbers? Numbers which are not mentioned in the P by Q format are called as irrational numbers. So all these rational numbers, irrational numbers, and entire these integers, whole numbers, all these concepts come under the term real numbers. So what is the title of our chapter then? Real numbers. Real numbers means these numbers contains all these rational numbers, irrational numbers, integers, whole number, natural number. So whatever the numbers we are using in this chapter, whatever the operations that we are doing in on those numbers, all those numbers are called as real numbers. But out of curiosity, I'm asking you, why the name real numbers only? We can simply call it as numbers, right? Why we are using the term real numbers? Because in the mathematics, we have one more concept called imaginary numbers. About this concept, you are going to learn in future. But to differentiate the number system from this imaginary numbers, we are giving the name as real numbers. So I hope you have revised all the concepts like natural numbers, whole numbers, etc. Let's go to the some more basic things that we want to know before learning the actual concepts in this chapter. The first concept is multiples. What do you mean by multiples? These are your primary standard concepts only. What do you mean by multiples of a number? Write the multiples of 10, for example, or 20. Take a number 20. Write the multiples of it. 21s are 20, 22s are 40, 80, 100, 120, 140, so on. It keep on continuing. So just come and take fractions. Take another example, like take the number 10. So just list down the numbers on which tables this number 10 comes. ಯಾವ ಟೇಬಲ್ ಅಲ್ಲಿ ಈ ನಂಬರ್ 10 ಬರುತ್ತೆ ಅಂತ ಈಗ ರೈಟ್ ಮಾಡೋಣ. 10 ಈಗ 1 because 1 into 10 is equal to 10 only. 2 5s are 10. 3 it won't come. 4 won't come. 5 2s are 10. 6 it won't come. 7 8 9 and that 10 only. Notice or take another example 20. So just write down what are the in which tables this number 20 will come. 1, 2, 3 it won't come. 4, 5, 6, 7, 8 it won't come. 9 it won't come. 10, 11, 12. So maximum it will come in 20. So just observe carefully here 1 and the number. So any number you take, so it will by default it will be having the two common factors like the number itself and the number called 1. Any number, any large number you take, any prime numbers you take, or take 3 for example. So in which table 3 is coming? 1 and 3 only. So 1 and the number itself is the default factors of this any number. So what do you mean by factors then? So the number which are exactly dividing the another number. So this number is called as factor of 10. 2 is called as factor of 10 because 2 is completely dividing 10 and leaving the remainder as 0. See, 2 5s are 10. Remainder is 0. So we can say 2 is the factor of 10. Then we come to know the difference between these multiples and factors. So what are the difference you keep on monitoring here? See, multiples means the number value keep on increasing 20, 40, 60, 80, 100. So multiples always it will be large numbers. So what about factors then? Factors, the value is small only, right? So because the maximum factor we are getting is the number itself. Then the factors will be less than the actual number we have given. So the factors will always be small numbers. The second difference is multiples will having means it's keep on multiplying. It don't have end. So the value is infinite. Say for example, I want to write 20 into 60. So what is the multiple? 6 2s are 12. So 1200. What do you mean by 20 into 125? It gives some other value. So these multiples will keep on continuing. But what about these factors? Factors have the limited value only. See, 10 have 4 factors and 20 have 1, 2, 3, 4, 5, 6, 6 factors. So by this, what we can conclude is factors are having finite value. That means they can be countable. Correct. So this is a very basic concept required for this chapter. So while solving the problems, these are the small points you should keep in your mind to understand this chapter very clearly. So the next basics concept we are understanding here is prime numbers, composite number and co-prime numbers. Let's understand each number in detail one by one. First one is prime number. I am taking 2, 3, 5, 7. I am saying like 2, 3, 5, 7 are prime numbers. How I am saying? Just write the factors of 2. What you mean by factors? Just now we have learned in which tables this number 2 is coming. 2 from 1 is coming, 2 is coming. And what about 3? Factors of 3? 1, 3. 5, 1 and 5. 7, 1 and 7. You notice here the factors of these numbers are number and the number itself. That means 2 will completely divided by 1 and 2 will completely divided by 2 only. These kinds of numbers which are having the factors as 1 and the number itself are called as a prime numbers. See, prime numbers are the numbers greater than 1. See, that means you may have another doubt. Ma'am, 1, it is having, it will comes in a 1 table only. Can we call it as a prime number? No. 1 can never be a prime number. Okay. So, prime numbers will always be having a value greater than 1. 0 is also not a prime number. So, always greater than 1 means 2, 3, 5, 7. These numbers which are having factors as 1 and the number itself are called as prime numbers. Understood? Now let's go to the second concept, composite number. What do you mean by composite number then? Take any example 6. Okay. Write the factors of this number 6. In which table this number 6 is coming? 1. Okay. 2. Because 2 3s are 6. 3 2s are 6. And 6 only. So what are the factors of 6 then? 1, 2, 3, 6. Take another example. I'm saying 8. Write the factors for this number 8 now. 1, 2 4s are 8, 3 not divisible, 4 2s are 8, 5, 6, 7 and 8. So what you are observing, these numbers 6 and 8 are having more than 2 factors. By default, any number will be having 1 and the number itself as a factor. But here what we are observing, this number 6 is having more than 2 factors other than 1 and the number itself. These kind of numbers are called as composite number. What you mean by composite number then? These composite numbers are natural numbers that have more than 2 factors. So you are clear with composite numbers now, right? Let's come to the third concept, co-prime number. What do you mean by co-prime number? Take the example and we understood the concept of co-prime number. Take 2 and 3. Write the factors of 2 now. What are the factors of 2? 1, 2. What are the factors of 3? 1 and 3. Now, compare the factors between 2 and 3. Which is the common factor between 2 and 3 now? Simple, right? 1 only. Take another example. 8 and 9. Write the factors for 8. 1, 2, 4, 8. What are the factors for 9? 1, 3, 9. Correct. So what is the common element between these two numbers then? Which factor is common between 8 and 9? 1, right? Okay, here also 1. So that means composite numbers are the pairs of numbers. It should contain, co-prime numbers are the pairs of number. That means it should contain minimum 2 numbers that have no common factor other than 1. That means 1 should be the common factor between any 2 numbers. Those numbers are called co-prime numbers. You may get confused. ಮ್ಯಾಮ್ ನೇಮ್ ಅಲ್ಲಿ ಪ್ರೈಮ್ ನಂಬರ್ ಅಂತ ಇದೆ ಬಟ್ 8 ಮತ್ತೆ 9 ಬಂದು ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ಸ್ ಆಗುತ್ತಲ್ಲ ಹೌ ಕ್ಯಾನ್ ಯು ಕಾಲ್ ಇಟ್ ಅಸ್ ಕೋ ಪ್ರೈಮ್ ನಂಬರ್ ಸಿ ಕೋ ಪ್ರೈಮ್ ನಂಬರ್ ಮೀನ್ಸ್ ಎ ನಂಬರ್ ಶುಡ್ ಬಿ ಪ್ರೈಮ್ ನಂಬರ್ ದಟ್ಸ್ ನಾಟ್ ಎ ಕಾನ್ಸೆಪ್ಟ್ ಎ ನಂಬರ್ ಕ್ಯಾನ್ ಬಿ ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ಸ್ ಆಲ್ಸೋ ಎನಿ 2 ಪೇರ್ ಆಫ್ ನಂಬರ್ಸ್ ನಾವು ಕಾಂಪೋಸಿಟ್ ನಂಬರ್ ಕೂಡ ತಗೋಬಹುದು ಬಟ್ ಆ 2 ನಂಬರ್ಸ್ ಮಧ್ಯೆ ಇರುವಂತ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ಬಂದು 1 ಆಗಿರ್ಬೇಕು ಅಂತ ನಂಬರ್ಸ್ಗೆ ನಾವು ಕೋ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಅಂತ ಕರಿತೀವಿ ಸಿ 21, 22. Take this example and write the factors for it. 21 and 22, by seeing the number itself, we can say these are all composite numbers. Write the factors for 21 then. 1, then 3, 7, 21. And what are the factors of 22? 1, 2, because 2 11s are 22, 11, 22. So what is the common factor between these things? Only 1. So we can call 21 and 22 are the co-prime numbers. Hope everyone understood the concept of prime number, composite number and co-prime number. So we are going to the most important topic of this chapter, the fundamental theorem of arithmetic. Let's see what this fundamental theorem of arithmetic states. Every composite number. So what do you mean by composite number then? Composite numbers are the numbers which are having factors more than 2. That means I am saying 12 as a composite number. What are the factors of 12? 1, 2, 3, 4, 6, 12. And what they are saying, every composite number can be expressed as a product of primes. Now what I am doing, I am writing 12 as 4 into 3. Do you think 4 is a prime number? No. So I am just dividing this 4 into multiples of 2. So 2 is a prime number, 2 is a prime number, 3 is a prime number. So what can we write? 2 into 2 into 3. 2 2s are 4, 4 3s are 12. We are getting the original number. So every composite number can be expressed as a product of primes, and this factorization is unique. What you mean by the factorization is unique? Let us take another example. Say 17. No, 17 is not a composite number. Let's take another example, 34. So what I am going to do, I am writing the factor of this number. So 34 can be written as 17 to the 34, 17 into 2. So 17 is also prime number, 2 is also prime number. Here what is the product of prime we are getting? 2 into 2 into 3. Here what is the product of prime we got? 17 into 2. So by this we can conclude that for the number 12, the product of prime is this. But for 34, the product of prime is 17 into 2. Compare these two product of primes. So we can state that the product of primes is unique for each number. For number 34, 17 into 2, and this will be the product of prime for 34 only. It will never be the product of prime for 12. For 12, it will be having its unique prime product. Correct. So apart from the order in which the prime factors occur. Suppose here I have written 34 in terms of 17 into 2. I will just rearrange this order. 2 into 17. Do you think the value will change? Same, right? I can write 17 into 2 is equal to 2 into 17. That's what. Apart from the order in which the prime factors occur. So just revisit the statement once again. Every composite number can be expressed as product of primes. And this factorization is unique for each number apart from the order in which the prime factors occur. This is the core concept. You should have a clear understanding in this chapter. So let's see the factorization method once again. I am taking 16. So write the factors. That means 16 means I can write is 4. 4 4s are 16. And I can write 4 as 2 into 2. 4 as 2 into 2. So this method is called as factor tree. You already know about this method from your previous classes. Correct? So what will happen if I take another large example, like I will take 72. Let's factorize this number. So I'm just dividing it by 2. 2 3s are 6. 2 6 are 12. 2 1s are 2. 2 8s are 16. 2 9s are 18. 3 3s are 9. 3 1s are 3. That means what are the prime factors for this number 72? 2 into 2 into 2 into 3 into 3 into 1. Let's take the same example once again. And instead of 2, now what I am doing, I am going to start this number by 3. So let's divide 72 by 3. 3 2s are 6, 3 4s are 12. 3 8s are 24. Then 8 is divided by 2. 2 4s are 8, 2 2s are 4, 2 1s are 2. So what are the value we got? 3 into 3 into 2 into 2 into 2. So this is what the fundamental theorem states. Apart from the order in which the prime factor occurs, for each composite number, this value will be unique. See, for in the first case, for the number 72, I started from 2 and ends with the 3. But in the second case, I started to divide the number by 3 and end with 2. So how many factors coming here? 2 cube into 3 square into 1. How you are going to simplify this one? 3 square into 2 cube into 1. Both are same only, right? I am just replacing 2 cube into 3 square. Value will not going to change. So this is what the fundamental theorem of arithmetic states. So if we are writing the same fundamental theorem of arithmetic in general form, take the example 32760. So the factors of this 32760 numbers are 2 into 2 into 2 into 3 into 3 into 5, 7 into 13. In general form, I am representing this 2 as P1, the second term as P2, P3, and so on. I am representing it in a general form. So, in general, for any given composite number x, we factorize it as x equal to P1, P2 up to Pn. Where P1, P2, Pn are primes and is written in the ascending order. So here see 32760 is a composite number. Prime numbers. That's what this fundamental theorem of arithmetic states, and it can be represented using the general form as P1, P2, P3, etc. And this is the example. So whether I am writing this factorization in ascending format or descending format, the value will not going to change. Correct? So in general form, we are writing any factorization in ascending format. First 2, then 3, 5, 7, 30. So we are getting the value 32760. So this is the complete explanation of the concept fundamental theorem of arithmetic. In the next class, we are going to see the applications of this fundamental theorem of arithmetic. So that you are going to see by using this theorem statement, what kind of problems we are going to solve in future. So till that time, keep on revising this theorem and take care. Thank you. Bye bye. Found this information interesting? Then what are you waiting for? Subscribe to learn more information in an interesting way by registering to the website www.skysep.in or call to the number 9916023502 to get 50% discount. Thank you.